1. What is the difference between supervised and unsupervised learning? Answer. Supervised learning involves labeled data and aims to predict output from input data. Unsupervised learning works with unlabeled data to find patterns or groupings within the data. 2. Explain the concept of overfitting and underfitting in machine learning. Answer. Overfitting occurs when a model learns too well from training data, including noise, which reduces its ability to generalize to new data. Underfitting happens when a model is too simple and cannot capture the underlying trend of the data. 3. What is the difference between classification and regression? Answer. Classification predicts a discrete label or category, e.g., spam or not spam, while regression predicts a continuous outcome, e.g., predicting house prices. 4. What are precision, recall, and F1 score? Answer. Precision is the ratio of true positives to all predicted positives, recall is the ratio of true positives to all actual positives, and the F1 score is the harmonic mean of precision and recall, balancing both. 5. How do you handle missing data in a dataset? Answer. Common methods include deleting rows with missing values, replacing them with statistical values, mean, median, mode, or using advanced techniques like k-nearest neighbors, KNN imputation. 6. What is regularization and why is it important? Answer. Regularization is a technique to prevent overfitting by adding a penalty to large coefficients in the model, L1, L2 regularization. It helps maintain generalizability of the model to unseen data. 7. Explain the bias-variance trade-off. Answer. Bias is error due to overly simplistic models, leading to underfitting, while variance is error from overly complex models that fit the noise, leading to overfitting. Balancing bias and variance is key for a robust model. 8. What is cross-validation and why is it used? Answer. Cross-validation is a method to assess a model's performance by dividing data into training and validation sets multiple times, commonly using k-fold cross-validation. It improves the robustness of the model evaluation. 9. What is a confusion matrix and how is it useful? Answer. A confusion matrix is a table that shows true positives, true negatives, and false negatives, helping to assess classification model performance. 10. Explain the differences between bagging and boosting. Answer. Bagging, bootstrap aggregating, reduces variance by training multiple models on random subsets of data and averaging their predictions, while boosting sequentially trains models, with each model improving on the errors of the previous one. 11. What is the role of a learning rate in machine learning models? Answer. The learning rate controls the step size during gradient descent optimization. A too high learning rate may cause the model to miss the optimal solution, while a too low learning rate may result in slow convergence. 12. What is gradient descent, and how does it work? Answer. Gradient descent is an optimization technique used to minimize a cost function by iteratively adjusting model parameters in the opposite direction of the gradient to find the optimal values. 13. What are some common feature selection techniques? Answer. Common techniques include filter methods, e.g., correlation-based selection, wrapper methods, e.g., recursive feature elimination, and embedded methods, e.g., lasso regression. 14. What is principal component analysis, PCA, and why is it used? Answer. PCA is a dimensionality reduction technique that transforms features into a set of linearly uncorrelated components, helping reduce complexity while preserving as much variance as possible. 15. Explain the difference between ensemble methods like random forest and gradient boosting. Answer. Random forest is an ensemble method that combines multiple decision trees to reduce variance and improve stability. Gradient boosting builds trees sequentially, each improving on the errors of the previous tree, often achieving higher accuracy but being more prone to overfitting.